You wake up. Before your feet even touch the floor, you check your phone. Not for messages, for the weather. 72 degrees, clear skies, 0% chance of rain. You glance at it for less than 2 seconds, and then you stop thinking about it entirely. You already know what kind of day it's going to be. You know what to wear. You know if you'll need a jacket. You know, with almost total certainty, that the sun will be exactly where it's supposed to be. That certainty feels so small, so obvious, that it barely registers as a thought at all. But here's what that 2-second glance is actually hiding. For most of the time humans have existed on this planet, that certainty didn't exist. Not because forecasting hadn't been invented yet, because there was a moment, a real documented moment in our history, when the sky itself broke its promise. When it didn't just rain or storm or cloud over for a season. It went dark, and it stayed dark for years. And somewhere underneath that darkness, in the cold and the ash, a small number of humans had to figure out how to survive a world where the sun had, for all practical purposes, disappeared. You are only here, checking your weather app, mildly annoyed if it's overcast, because they did. Let's put this in a time scale that actually means something. Modern humans have existed for roughly 300,000 years. Written history, the stuff we actually have records of, only goes back about 5,000 years. Everything before that is silence. Bones, tools, ash layers, no diaries, no witnesses. Somewhere in that silence, around 74,000 years ago, a volcano in what is now Sumatra, Indonesia, Lake Toba, erupted with a force so extreme that geologists still use it as the benchmark for supervolcano. Not a metaphor, a technical classification. The eruption is estimated to have thrown around 2,800 cubic kilometers of ash, rock, and gas into the sky. To put that into a number your brain can actually hold on to, that's enough material to bury the entire continental United States under roughly a foot of debris. Sulfur particles from that explosion spread through the entire atmosphere. Global temperatures may have dropped by as much as 3 to 5 degrees Celsius. For years, not days. Some researchers believed the sun would have appeared dimmed or entirely obscured across large parts of the planet for months, with disrupted seasons continuing for years afterward. Compare that to your worst week of bad weather, a canceled flight, a rained-out weekend. Now stretch that disruption across 6 full years, apply it to your entire food supply, and take away any modern tool you'd use to cope with it. That's not an inconvenience, that's an extinction-level event. And for a while, many scientists believed it very nearly was one. Once you understand what actually happened during that eruption, and more importantly, what people did in response to it, you'll never look at an ordinary blue sky or a stocked grocery store or even a group of close friends the same way again. In the early 1990s, a geologist and anthropologist named Stanley Ambrose, working at the University of Illinois, noticed something strange buried inside human DNA. When researchers studied human genetic diversity, essentially how different we all are from one another at a genetic level, they found something that didn't make sense for a species as old and widespread as ours. Our genetic diversity was surprisingly low, lower than you'd expect from a species that had already been spreading across continents for tens of thousands of years. Something had thinned us out. Something had squeezed the human population down to a small, fragile number, and then let it slowly recover. Ambrose connected this genetic clue to the ash layers geologists had already been finding, dated to the same window of time, and proposed what's now known as the Toba catastrophe theory. His argument was that the Toba eruption triggered a volcanic winter so severe that it crushed the human population down to somewhere between 1,000 and 10,000 breeding individuals. Sit with that number for a second. 10,000 people. That's smaller than most college campuses. That's the entire surviving human race at one point, fitting comfortably inside a mid-sized concert venue. But surviving the collapse of the food chain isn't just a matter of finding calories. It's a matter of psychology, of how humans behave when the ground beneath them, quite literally, stops making sense. This is where a second thread of research becomes important. Archaeologists working at Pinnacle Point, a cave system on the southern coast of South Africa, have uncovered something remarkable. Evidence that small human groups living right around this same period weren't just surviving. They were adapting with startling sophistication. Shellfish remains, refined stone tools, early pigment use possibly for symbolic or social purposes. While the interior of the continent was drying out and dying, these coastal communities pivoted almost entirely toward the ocean, a food source that didn't collapse the way grasslands and herds did. It didn't freeze, it didn't burn, it simply kept giving, tide after tide, regardless of what the sky was doing above it. That single decision, moving toward a stable resource instead of clinging to a familiar but dying one, may be one of the earliest recorded examples of adaptive human behavior under extreme environmental stress. And then there's a third piece of evidence, one that actually complicates and enriches the whole picture. In 2013, a research team led by geoarchaeologist Michael Petraglia excavated a site in central India and found something unexpected, a thick, unmistakable layer of Toba ash, with human-made stone tools found both directly beneath it and directly above it. Same style, same technique, no interruption. In other words, in this region at least, life didn't stop. People didn't vanish. They kept making tools, kept adapting, kept living, straight through the eruption and its aftermath, as if the end of the world had simply been a difficult season. Put these three threads together: the genetic bottleneck, the coastal adaptation, the uninterrupted tool making, and you get a much stranger, more human story than everyone nearly died. You get a picture of a species that didn't survive through strength or luck or sheer numbers. We survived through flexibility, through the willingness to abandon what used to work the moment it stopped working. Here's the part almost nobody knows, and the part that quietly reframes the entire story. For years, the Toba catastrophe theory was treated as settled fact. The eruption nearly wiped out humanity. Full stop. It's the version that ends up in documentaries and textbooks because it's dramatic and clean. But newer evidence, including that Indian excavation, suggests something far less tidy. It suggests the disaster wasn't uniform. In some regions, populations may have crashed catastrophically. In others, like that Indian site, like those South African coastal caves, life may have barely been disrupted at all. The volcano didn't erase humanity. It ran a filter across the entire species simultaneously, in different environments, with different outcomes. Some groups had no answer to the crisis and vanished. Others had, almost by accident, already built the exact behaviors needed to survive it. Proximity to stable food sources, tight social cooperation, a willingness to change strategy fast. In other words, the eruption didn't create human resilience. It revealed which humans already had it. That's the twist. It wasn't a test the species passed together. It was a test that exposed who had already been quietly preparing for a crisis nobody could have predicted, simply by living in a way that didn't depend on everything staying the same. So what erased this part of our history from everyday awareness? What made this story feel like ancient trivia instead of something that shaped who you are? Certainty, not a single invention, not one villain you can point a finger at, but the slow, cumulative effect of a world engineered to remove uncertainty from daily life. Refrigeration, global supply chains, weather satellites, insurance, emergency infrastructure. Every one of these things is a genuine gift. Nobody's arguing we should romanticize starvation under a volcanic winter, but there's a quiet cost buried inside all that convenience. We've been slowly disconnected from the instinct that once kept our species alive. The constant low-level awareness that the environment can turn on you and that your survival depends on the people standing next to you. Modern life is so stable that resilience has become theoretical instead of instinctive. We plan months ahead, assuming tomorrow will look like today. That certainty feels normal, but for most of human history, it was a luxury. Think back to this morning. You checked your phone, 72 degrees, clear skies. That small ordinary certainty, the fact that you never questioned whether the sun would rise, isn't humanity's default. It's the exception, a luxury made possible by a handful of ash-covered, frightened survivors who endured a catastrophe 74,000 years ago without ever knowing what they were preserving. They didn't move because they were brave. They moved because staying meant dying. They didn't help strangers because it was noble. They helped because in a broken world, survival meant staying together. That instinct never disappeared. It passed through ice ages, floods, famines, and eventually, into you. So the next time your day is thrown off by a bad forecast or a canceled plan, ask yourself,